Okay, so in 8.6, we are still talking about systems. However, now we're talking about systems of linear inequalities. So instead of the equal sign, we're going to have less than, greater than, less than or equal to, greater than or equal to. When we solve a system of linear inequalities, since it's not an equal sign, there's going to be more than one answer. So there's going to be infinitely many answers. So we always solve that by graphing. So the first thing you're going to do is you're going to sketch the line that corresponds to each inequality. So remember when we were sketching just single inequalities, we were doing dashed lines or dotted lines if it was just less than or greater than, solid lines for less than or equal to or greater than or equal to. Then you're going to lightly shade the half plane that's the solution for the inequality, and the graph of the system is the intersection of the half plane. So basically, wherever you're shading, that's the same for each of the lines that you're talking about. I like to use multiple colors or shade in different directions so that I can tell a little bit easier where they're both being shaded or where all 3 or 4, however many lines that you have, are being shaded. That way you can just figure out where your solutions are a little bit easier. So in 1 and 2, we're just going to sketch the graph of the systems. You don't have to write these in slope-intercept form. I find them a little bit easier if you do, but that's totally up to you. So for this first inequality, x plus y is less than or equal to 3, I'm going to subtract my x to the other side and use y is less than or equal to negative x plus 3. And then for the second inequality, x minus y is less than or equal to 1, I'm going to subtract by x. And divide by a negative to get that y positive. Now remember, when you divide or multiply by a negative, you have to flip that inequality. So it becomes y is greater than or equal to x minus 1. So we're using y less than or equal to negative x plus 3 and y greater than or equal to x minus 1. So next thing that I'm going to do is I'm just going to create my graph. And then I'm going to start graphing my lines. So y is less than or equal to negative x plus 3. I'm going to start up at positive 3. Negative x means my slope is negative 1. So I'm going down 1 over 1. It's less than or equal to. So it's going to be a solid line. And then less than, we shade below the line. If you're not sure, you can always test a point. If it doesn't go through the point 0, 0, that's the point I always use. So if I plug 0 in for y and x, I get 0 less than or equal to 3, which is a true statement. So I would shade in the direction of 0, 0. And then I'm going to graph my second line. So y is greater than or equal to x minus 1. I'm going to start at negative 1, x, so my slope is just a positive 1, up 1 over 1. It's greater than or equal to, so it's going to be a solid line. Greater than, I shade above the line. So again, if you're not sure, plug in a test point. It doesn't go through 0, 0. So plug in 0 for x and y. 0 greater than or equal to negative 1 is a true statement. So I would shade in the direction of that point so they overlap in this area right here. So that little section to the left of my graph is going to be where all of my solutions are. Okay, so we're going to do the same thing for number 2. I'm going to solve those equations for y to make it a little bit easier. So I'm going to subtract my 2x and divide by my -3, which is going to require me to flip my sign. So I end up with y greater than or equal to 2/3 x minus 2. And then the second equation, I'm going to subtract my x. So I end up with y greater than or equal to -x plus 2. So now it's just a matter of graphing those. So for the first equation, y is greater than or equal to 2/3 x minus 2. I'm going to start at -2. My slope is 2/3, so I'm going to go up 2 and over 3. It's greater than or equal to, so it's going to be a solid line. And greater than, we're shading above that line. Again, you can always test a point if you're not sure. And then the second equation, y greater than or equal to -x plus 2. I'm going to start at +2. I have a slope of -1. It's greater than or equal to, so it's a solid line. And then greater than is going to be above. So again, if you need to test your point, 0, 0 does not go through that. So 0 greater than or equal to 2 is not a true statement. So you're going to shade on the opposite side of that point. So we end up with the overlap in this top right side of the graph. Okay, so same thing with 3 and 4. We're just graphing and finding where our solutions are at. One thing you want to keep in mind is that when you have x greater than, less than, whatever a number, those are vertical lines. And when you have y greater than, less than, whatever a number, those are horizontal lines. So don't let those confuse you. It's just either a vertical or a horizontal line. If it's x in a number, vertical, y in a number, horizontal. So same thing we're doing here. So x is greater than -4. We're going to go over to -4 on the x-axis. It's just going to be a vertical line. Since it's just greater than, it's going to be a dotted or dashed line. Greater than, so x numbers get bigger as we go to the right. So greater than is going to be to the right. And then our second line, x is less than or equal to 2. We're going to start at 2 on the x-axis. It's less than or equal to, so it's going to be a solid line. Less than is going to go to the left. So that area where they're both shaded is in between those two lines. So in number 4, we're doing the same thing, but it's just y and a number. So they're horizontal lines. So we're going to start with our first inequality. So y is less than 3. We're going to start at 3 on the y-axis. It's just less than, so it's going to be a dashed line. Less than, numbers get smaller on the y-axis as we go down. So less than, it's going to go below that. And then our second line, y is greater than -2. We're going to start at -2 on the y-axis. Again, there's no or equal to on that, so it's a dashed line. We want to go greater, so to go greater than, we got to go up. So our common shaded area is in between those two lines. Okay, so 5 and 6, we are looking at more than 2 inequalities. This doesn't change how we do it. So in number 5, x plus y is less than or equal to 4. I'm going to write that so that it's solved for y. So I'm going to subtract my x on both sides. And I'm going to use y is less than or equal to -x plus 4. And then I have x greater than or equal to 0, y greater than or equal to 0. So I'm just going to start with my graph. So when I graph y less than or equal to -x plus 4, I'm going to start up at 4. And then my slope is -1. So down 1 over 1. And then it is less than or equal to, so it's going to be a solid line. Less than is going to be shaded below that. And then x greater than or equal to 0. So x is 0 right here. So it's going to be a solid line. Greater than is going to go to the right. And then y greater than or equal to 0. Y is 0 right here. So horizontal line. And greater than that is going to be above. So all of those are shaded in the same area that form this little triangle right here. So any value in that triangle is going to be a solution of that inequality. So we're doing the same thing for number 6. So if you feel confident, pause the video, try it yourself, then come back and compare. So we've got our graph first. So y is greater than -5. That's going to be our horizontal line. So I'm going to start at -5. It's going to be a dashed line. Greater than would shade above. And then x less than or equal to 2 is going to be a solid line since it's an or equal to. Less than is going to shade to the left. And then y less than or equal to x plus 2. I'm going to start up at 2. I have a slope of 1. So I'm going to go up 1 over 1. If you need to go the opposite direction, you can. So instead of up 1, right 1, we just go down 1, left 1. It's an or equal to. So we're just going to connect those. And then y less than or equal to x plus 2 is going to be shaded below that red line. So the place where they all have in common is going to be in this triangle here. Nothing's changing in number 7 except we're going to have 4 lines instead of 3. So we're still going to start with making sure all of our lines are solved for y. So x minus 2y less than or equal to 4, I'm going to subtract my x and divide by negative 2. So remember, you got to flip your inequality. And then 3x plus 2y greater than or equal to 8. I'm going to subtract my 3x and divide by 2. And then my x plus y less than or equal to 6, I'm going to subtract my x. I don't need to change my x greater than or equal to 1. So I'm going to make my graph. So x is greater than or equal to 1. I'm going to start at 1. It's going to be a solid line. Greater than is going to go to the right. My second inequality was the one that became y greater than or equal to 1/2 x minus 2. So I'm going to start down at negative 2, up 1 over 2. It's going to be a solid line because of the or equal to, and it's greater than or equal to, so I'm going to shade above that. My third inequality became y greater than or equal to negative 3/2 x plus 4. So I'm going to start at 4, and I'm going to go down 3 and over 2. It's got an or equal to, so it's a solid line. Greater than is going to be shaded above. And then my last line, my last inequality became y less than or equal to negative x plus 6. So I'm going to start up at 6. I have a slope of negative 1. So down 1 over 1. It has an or equal to, so it's a solid line. And it's less than, so it's going to be shaded below that. So the place where they all have in common is this little quadrilateral in here. Okay, so in number 8, we are writing the system of linear inequalities. So we're just going to say, okay, I have these so many lines, they're shaded here. What are my inequalities? All of that. So my suggestion would be if you have horizontal or vertical lines, start with those first because that's the easiest. So we have a vertical line right here that goes through 1 on the x-axis. So right off the bat, we know that it's going to be x, whatever our inequality is, 1. Now we're shading to the right of that. So to the right is going to be bigger x values. So it's going to be greater than 1. And now we have to know, okay, well, is it going to be greater than or equal to, or just greater than? Well, it was a solid line, so we know we're going to include that or equal to. So one of our inequalities is that x is greater than or equal to 1. So then we move on to the next line. So I'm going to use this one here. So we have this point at 0, 6, and then this point here at 3, 0. So we know that our y-intercept is 6. And then we know that it's going to intersect this point at 3, 0. So I'm going to go down 1, 2, 3, 4, 5, 6 over 1, 2, 3. So 6 over 3 simplifies down to 2. So that's going to be my slope. It's shaded below this line. So below would be less than. It's solid, so it has to have that or equal to. So we know our next line is y less than or equal to 2x plus 6. Sorry, negative 2x plus 6 because we went down 6. So we have a negative slope. And then our third line has a point at 3, 0. And then this point here at 0, negative 3. So we know that we have a y-intercept at negative 3. And if we find our slope, we're going up 1, 2, 3 over 1, 2, 3. So 3 over 3 equals 1. So it's a slope of 1x. Remember, you can put the 1, you don't have to put the 1. It's shaded above that line, so above would be greater than, and it's a solid line, so it has the or equal to. Okay, so all you're doing is finding slopes and y-intercepts so that you can write the equation. And then once you have the equation, you just have to figure out, is my inequality less than or greater than? And then if it's a solid line, add your or equal to. If it's a dashed line, no or equal to. Okay, so we're doing the same thing in number 9. We're just writing the system of inequalities. So again, start with any vertical or horizontal lines that you have. So we have a vertical line here at x equals negative 2. It's solid, so we know it's going to have the or equal to. We're shading to the right, so that's going to make it bigger. So x is greater than or equal to negative 2. We have another vertical line here at x equals positive 2. It's solid, so it's going to have the or equal to, but it's shaded to the left. So to the left, x values get smaller. So x is going to be less than or equal to positive 2. So now we just have our two lines that have a slope to them. So to get from negative 2, 3 to 2, 1, we're going down 1, 2 over 1, 2, 3, 4, which is going to give us the slope of negative 1/2. And it's going to cross that y-axis at 2. So we know our y-intercept is 2. It's shading below that, so it's going to be less than, and it's a solid line, so it's going to be less than or equal to. And then our last line here, to get from negative 2, negative 3 to 2, negative 5, we're going to go down 1, 2 over 1, 2, 3, 4, which simplifies down to negative 1/2. So we have a slope of negative 1/2 x. it's going to cross the y-axis at -4. So we have a y-intercept of -4, and it's shading above that. So it's going to be greater than, solid line means greater than or equal to. So those are our 4 lines that are going to form that system of inequalities. So that is 8.6, which is the last section in this chapter. So your homework will be posted in the actual assignment and in RenWeb, in the lessons on RenWeb. It'll be due on Friday by 11 o'clock a.m. If it's not to me by 11 a.m., it is late. Make sure you're turning it in on time, which means your Chapter 8 test will be next Tuesday. Okay, it'll be online, and it will be during that 11 to 12 time frame. Okay, so you will have to be in our class taking this test from 11 to 12. After our class is over, I'm not accepting any more tests. So once it's up, it's up. Okay, so if you have questions, let me know. Email me, get on the Zoom call, request a Google Meet. Just let me know if you get stuck on anything.